Hi, in this video, we're going to introduce the duration of the bond. So from previous videos, you should be able to calculate the price of a bond given its face value, maturity, coupon rate, and the yield to maturity. And the question is, what if the yield increases by a little bit or decreases by a little bit while keeping all others constant? So what's going to be the change in the price of the bond? How much is going to be the change, and how sensitive is the bond price to the change in the yield? Okay, and that's going to be answered by the duration and the modified duration. So we'll illustrate the changes and sensitivity here using two examples here. Okay, so suppose I have two different bonds. They both have the same face value, which is £1,000, and the same maturity, which is 5 years. Okay, but the first bond would have a coupon rate of 1% and the second 8%. So let's calculate the price of both bonds. But first, let's fix the yield to maturity at 5% here. Okay, so hopefully you still remember how to do the calculation for the bond price. You can either use it. You can either use the pricing formula, which is the year-by-year discounting and adding them up together, or you can use a bit of a shortcut using the annuity formula here. Okay, let's first use the year-by-year method here. Okay, so 1% coupon rate means the first payment is going to be 10 divided by 1 plus 5%, and then 10 divided by 1 plus 5% to the power of 2, and then all the way to the last payment, which is 1,010 over 1 plus 5% to the power of 5. And if you plug in these numbers to your calculator, it should give you a price of £826.82 here. Okay, so now let's increase the yield to maturity to 5.5%, which is not a drastic change, but it's going to affect our bond price. And as we know, it's going to decrease the bond price because that yield is in the denominator here. Okay, so let's calculate the bond price, but using the annuity formula for the coupons, and then add the final payment of the face value. Okay, so now the coupon stays the same. It's still 10, but divided by 5.5%. Okay, and then 1 minus 1 over 1 plus 5.5% to the power of 5, and add the face value here. Okay, in this case, this is only going to be 1,000, not 1,010. Okay, be careful. So 1 plus 5.5% to the power of 5. Okay, again, if you plug in these numbers to your calculator, you should get a price of £807.84. So as we can see, this new price is lower because the yield is higher now. And we can calculate the relative change as a percentage here. So you can use the new price minus the old price and divide it by the old price, which should give you a change of 2.3% in the price. Okay, so basically, if we increase the yield by 0.5%, the price is going to drop by 2.3%. Okay, so let's use the same procedure on the second bond here, which has a coupon rate of 8%. Okay, let's still use the annuity formula first, which is going to be 80 divided by 5%, and then 1 minus 1 over 1 plus 5% to the power of 5. And then the face value here divided by 1 plus 5% to the power of 5. And this should give you a price that is higher than the face value because the coupon rate is higher than your yield to maturity, and that gives you the signal that this bond is going to be priced at a premium. So if you do the calculations here, you should get £1,129.89. Right? So similarly, we can do the 5.5% as the yield to maturity, but now I'm going to skip the calculations. So the new price is going to be £1,106.76. Right? And then we still need to calculate the relative change in percentages. So if you use the new price minus the old price divided by the original price, you will get a price decrease of 2.05%. Okay, so what can we conclude from here? So if all else constant, the higher the coupon rate, the less change or less drop in the price it is if we increase the yield by the same amount. Okay, so it's less sensitive to the change in the yield if we have a higher coupon rate. So why is this? So intuitively, you can think of this bond here provides you more value in the first few years or in the early stages. While compared to this one, most of the value comes from the face value, which is at the end or at the maturity of that bond. So since we're discounting all the future values, if I can be compensated or be provided more value at the start, then it's going to be less sensitive, because discounting is an exponential operation. The further into the future it is, the more we discount it. So if we are provided with more value at the early stages, it's not discounted that much. So if you change the discount rate, as long as it's not too drastic, then it's going to be not as sensitive as those bonds who has more value that's been paid at maturity. Okay, so in this case, this bond here is less sensitive than the first one. So now we need a unified way to quantify the sensitivity here, which brings us to the Macaulay duration. So we'll first give you the formula for the Macaulay duration, and we'll do the derivation in future videos. Okay, so the formula here is going to be D Macaulay here. So it's going to be a big operation here. Okay, so on the numerator, it's going to be very similar to the bond price. The only difference is that you can see we are using T multiply the cash flow here, right? So I should write it here. Over 1 plus RT, or in this case, we can just use the yield because we're not using the spot rates here. But if you're provided with spot rates, you can still use this, the spot rates. But in this case, we're using a yield here. Okay, so you have from year 1 to year n. Okay, t equals 1 to t equals 10, and t equals n here. Okay, and then on the denominator here, you have the price of the bond. Okay, so let's take a look at this thing here, which is the numerator here. So the only difference is this bit, which is the year itself. You multiply the cash flow with its respective year. Okay, so this can be intuitively considered as a weight for each payment, and is weighted in terms of time. Okay, so it's a time-weighted cash flows, and then you divide it by the price itself. Okay, and then you have the Macaulay duration. So let's use the Macaulay duration on the first on these two on these two bonds with different coupon rates. So let's just plug in the numbers. We'll illustrate using the first one. Okay, so the D Macaulay for the first bond is going to be 10 times 1. Okay, and then 1 plus 5%. We're using the original yield here, not the new yield. Okay, so the original yield is 5%, and then plus 10 times 2 here, 1 plus 5% to the power of 2, and then 10 times 3, 1 plus 5% to the power of 3, and then 10 times 4, and to the power of 4, and the last payment, which is going to be 1010 times 5 divided by 1 plus 5% to the power of 5. Okay, and all of this divided by its price, which we already have, which is 826.82 pounds. Okay, and this should give us a number that is close to 4.89 here. Okay, so we can say the duration of the first bond is 4.89 years. Okay, so the unit, you could say years, or you can just say 4.89 here. Okay, and we can do the same for the second bond, which should give you a duration, or a Macaulay duration, of 4.36. Okay, so as you can see, a higher duration is more sensitive to the change in the yield, while the lower duration is less sensitive to the change in the yield. And with the calculation for Macaulay duration, you can compare different bonds with different coupon rates, maturities, or face values And intuitively, you can see which bonds are more sensitive to the change in yield and which are less. Okay, so this provides us with a way to compare with different bonds. But still, it didn't answer the question of by how much would it change. That would require us to use the modified duration, which we'll explain in the next video. And I'll see you there.